Assalamu alaikum warahmatullahi wabarakatuh. Dear students, I welcome you all for today's class. Okay, so this is going to be the last segment. This is going to be the third part, the last part of this chapter. Okay, inshallah. So I'll try to finish, I'll try to wrap up all the concepts today, inshallah. Okay, so this is chapter 15 and it's 15.3 class. Okay, so let's move ahead. Okay, so we are going to discuss the third topic of this lesson, which is known as radiation. Okay, so previously we discussed about conduction, convection. We discussed that conduction happens in solids, okay, and it doesn't travel in air. Air is a very good insulator, that is, it is a poor conductor. Conduction doesn't happen in air or any other gases. And then we discuss regarding convection. We discussed that convection, it happens mostly in the liquids and also in other fluids, okay, and also in gases. Okay, so we discuss these two topics, okay, and we also discuss on lots of other topics as well related to these two topics. Okay, inshallah, today we are going to discuss about radiation, which is the last topic of this lesson, very important one. Okay, so what is radiation? So for example, a very good illustration which is there in the textbook, it's regarding this heater. Okay, heater which is usually which is found inside a bathroom. Okay, so when someone takes a bath and comes out to warm himself or herself, they use this machine which is known as heater. Okay, when you switch on the button, the heat directly comes from the heater, and it and goes, and it falls on your skin. Thereby you can yeah, realize that the heat spreads throughout our body. But let me ask you one question: how did the heat travel towards your body? How did it reach you? See, in terms of conduction, convection, we always, I discuss that it needs a medium. Like for conduction, it needs solids. For convection, it needs uh, air or liquid, and so on. Okay, fluids. It needs fluids. But here in radiation, the unique thing in this radiation, thermal radiation process, is that you don't need any medium here. Okay, and the first point which I'm going to discuss here regarding radiation, that it travels, this heat, it travels in a straight line, just like light. You know very well that the light travels in a straight line and it has its own standard speed, correct? Okay, so this radiation, it happens in a similar fashion. Okay, so this is point number one, that the heat, radiation, thermal radiation, it travels in a straight line. Okay, and number two is regarding any device which gives thermal radiation, it has its own unique design. Okay, that is, for example, the bathroom heater includes a specially shaped, very shiny reflector, okay, similar to the reflector behind which you find behind a fluorescent light or in a torch. Okay, so what message these 2 points give us? This is the message, that is, the thermal radiation, it works like a light, a ray of light. Okay, it travels in a straight line, and it also needs something, in a shiny surface to reflect and then travel. Okay, so radiation, thermal radiation, is the transfer of energy by infrared waves. Yes, so this is the same infrared ray which we have studied in electromagnetic waves chapter. Yes, so this is just more like a light. It travels in a straight line. Okay, it reflects, it refracts. Okay, so then how do we receive the how do we receive the heat from the sun? Yes, it's through thermal radiation. Okay, so this thermal radiation is a type of heat transfer that can even travel through a vacuum. Okay, and it travels at the speed of light. Okay, that is 3 into 10 to the power of 8 miles per second. Okay, 3 into 10 to the power of 6 kilometer per second. Okay, and gases tend to allow radiation through better than liquids. uh, okay, and liquids, they allow radiation better than solids. Okay, so now it's very clear that radiation, it travels in vacuum. Okay, and gases, they tend to allow radiation better than the liquids, and liquids, they allow radiation better than the solids. Okay, so this concept is very clear now. It's regarding radiation. Okay, so now let us look into a few applications where this is used in daily lives. Okay, so mostly this thermal radiation, this concept is applied in military purposes. This is a thermal imaging camera. That is, through this camera, a military person can visualize, can see living beings like people and animals, even though the place is dark. How? Because we human beings or any other animal, we emit heat from our body. Okay, so this heat which emits out of the body, it is in the form of thermal radiation, that is IR radiation. So this camera, what it does is it receives, that is it absorbs, that is it visualizes this radiation which comes out of the human body. Okay, this is a picture, this is a sample picture. This is how it looks like when someone weaves through this camera. So this is the weave which a person will get when he looks through this camera. Okay, so this is one application of thermal radiation concept, and these are thermal imaging cameras. Okay, you have to remember this name. This is known as thermal imaging camera. Okay, so this can detect objects giving out IR waves, that is thermal radiation. And another concept and another application of this thermal radiation is thermal imaging in diagnosis. Yes, thermal imaging is also useful during diagnosis. That is, the meaning of diagnosis is finding out regarding a disease, finding out what kind of disease a person has. This is called as diagnosis. Okay, so nowadays it's it's a pandemic. This is what they say, we have a pandemic. Okay, so infection is being, viruses are being, they are infecting people. This is what they say, and they are using this thermal imaging camera to to just find out people who are sick, who have high temperatures. Okay, so this is a sample of that camera, the image of the camera, which you know can be, which will be shown, okay, to a person when he uses that kind of thermal camera or thermal imaging appliances or devices. Okay, so this thermal imaging device can be also used as a tool, okay, for diagnosis, for catching people who have infections. This is what they are doing in Dubai. You might have seen the video which came from Dubai. In UAE, the police is using thermal cameras in market areas, okay, and during uh, in places where people gather. Okay, so this is one application of thermal imaging cameras. Okay, so now let's discuss about few more concepts, like there are two things which you need to know, very important with respect to this topic, to this lesson also. Okay, so one is, number one, it's reflector. Now, what is a reflector? Okay, the name itself, it gives you an idea. It is regarding something, okay, some reflection or so. Okay, so similarly, okay, this radiation, what happens is there is radiation. I told you that this thermal radiation, it just behaves like a light, like a light ray. So how light reflects, even this thermal radiation also, it reflects when it falls on certain surfaces. Okay, so only it get reflects on when it falls on highly polished or shiny surfaces, or also when the surfaces are white enough, they reflect. Okay, so they reflect and they go back from where they came. Okay, so that is why firefighters, you know this is a firefighter. He is handling fire. He's playing with fire. Okay, so he's there to do his job. Now, what he needs to do is he needs to protect himself, right? So, what he does is he wears this reflective, suit. Okay, so this reflective coating suit he is wearing to protect himself from the heat, from the fire. Okay, so what will happen? The heat which comes out from the fire, it will not reach him. Instead, it will reflect back. Okay, so he'll be protected from the heat. And this coffee kettle or tea kettle, it has a shiny surface to reduce the rate of heat loss. Okay, this shiny surface is it's there in the inside as well, because the heat tries to escape. Okay, and it reflects back the heat. Okay, so thus the heat transfer doesn't happen through radiation. Okay, and another second thing which you need to remember is about radiators. Okay, radiators are those devices which absorb. Okay, they are just the opposite of reflectors. Okay, so these are the very poor reflectors. They absorb the heat, they absorb the radiation, and they pass it on to the other side. Okay, see, for example, this is a solar panel. Okay, so this solar panel has been coated with black color. Okay, some kind of black color, substance. So what does this black color coating does? When it is placed under sunlight, it absorbs the sunlight, and you know it converts that sunlight into electrical energy. Okay, so this radiator, it does the absorption of the thermal radiation. Okay, so it serves the purpose for which it has been manufactured. Okay, and number two, this is a heat sink. This whole setup is known as heat sink. That is the fan here, okay, uh, which sits on a transistor, which it belongs to the motherboard of a computer. Okay, so this transistor, more often it gets heat up, it gets hot enough. Okay, this heat should be transferred, should be radiated out. That's why this fan is coated with a black color, so that it radiates heat in a very efficient way. And also this transistor is also coated with black color. Okay, so because it gets heat it up, it has to radiate the heat. That's why it's coated with black, and this is known as heat sink. This whole setup is known as heat sink. Okay, so matte black and dark surfaces are very good radiators, or otherwise they are very poor reflectors. Okay, this you have to remember always. Okay, now here is an experiment. Here is an investigation process. Okay, where you can really understand this matte black and shiny surfaces properties, how they absorb or reflect light, that is radiation. Okay, see, for example, okay, so let me go into this experiment. What you need to set up, you need to set up few appliances. Okay, few apparatus. Like for the example, you have to have a bulb. Okay, placed in this way in the center, and half of the area of the bulb you have to paint it black. Okay, and half of the bulb you have to paint it with a shiny surface, or a shiny white paint, or something like that. Okay, then you have to place two thermometers. Okay, on the left, and then on the right. On the left, on the right, that is just next to the black surface, the black painted surface. And another thermometer just next to the white shiny surface. You have to place that. Okay, so when you switch on the light, what happens is that you will notice that the level of the mercury on the right side, that is which is next to the black surface, it rises up. Okay, so it shoots up. Okay, whereas this thermometer, which is next to the shiny surface, doesn't shoot up, doesn't go up. So this means that this surface, this area, this black matte surface, or black painted area, it radiates heat much faster than the shiny surface, and that is why this thermometer shoots up, shows temperature. Okay, so this is a very good example. This is a very good experiment investigation method to show this concept of radiators and reflectors. Okay. Okay, so our third topic today is regarding energy efficient houses. See, most of the time, in Europe and Caucasian nations, that is in the Western nations, the climate is too cold. Okay, sometimes it even goes to sub-zero levels. That is, the temperature goes below 0 degree Celsius. Okay, so for that, they have to keep themselves warm enough. They have to keep their houses warm, so they need to lit fire, or have some electronic heating system inside their houses. At the same time, they have to save energy. They don't have to let all the heat escape from their houses. That is, they need to have a very efficient system inside their homes. Okay, so for this, what they do, what they have, the system which they follow is known as insulation. Okay, so they insulate their houses with various kind of materials. Okay, it is based on various technology. Okay, so this is how they are able to keep their houses energy efficient. That is, okay, that is, they don't want to waste the energy. Okay, they want to save the energy as much as possible. Okay, right. So first thing is, you need to know that if you take a house, okay, there are numerous ways how the heat escapes. Okay, the heat escapes, majority of the heat escapes through the walls. Okay, through the walls, 35%. Then comes the roof, which allows the heat to escape, okay, at the rate of 25%. Then the windows, 10%. Okay, then the door, 15%. Then the floor, which is at the rate of 15%. Okay, so this is how heat gets escaped through the houses, through the house, from the walls, from the roof, from the windows, from the door. Okay, so now people have to take care of these things. That is, the walls, the roof, the windows, and the doors, and the floor. So I have a table here which gives you an idea, okay, how this is managed. That is how heat loss is reduced by doing few steps. That is, applying some kind of strategy. That is, for example, we take the doors. Yeah, they do allow the heat to escape. That is why, okay, they have this kind of setup which is known as drought excluders. What are they? We'll be discussing this inshallah in the coming slides. Okay, I'm just giving an introduction. Windows, they have this double glazing technology, okay, which saves the heat from escaping. Roof, they have loft insulation technology. Floors, they have carpets. Okay, so this is, I think this is easy to understand. And walls, they have cavity wall insulation. Okay, so these are the places from where the heat escapes, and these are the methods which are used, or the technology which are used to save the heat from escaping. Okay, so I think it's easy enough to understand. So let's move ahead. Let's learn about the walls first. Okay, so this is known as cavity wall insulation. So this is very easy to understand. See, basically in our houses we just have one wall made of bricks, whereas there in the Western nations they have two walls like these, and in between these walls there is a cavity. That is, there is a gap which is left deliberately. Okay, it is left deliberately. Okay, this is known as cavity or air gap. Okay, and this is not just left empty, but it is also filled with glass fiber insulating wool. Okay, this is a insulating wool, glass fiber insulating wool, which is used to stop the convection currents in the air gap transferring the heat. Okay, so what is that concept? What does this mean? What does this do? How does this doesn't allow the heat to escape? Huh? So basically, these two walls, they stop heat transfer through various methods like conduction, convection, in radiation. We discussed that conduction it happens only through metals. Okay, by having these bricks which are not metals, this will stop conduction. Okay, this will stop conduction. Then when we have this gap, it will also help to stop conduction, because conduction doesn't travel through gases. So this will stop conduction as well. Then number two, convection. How does it get stopped here? When we have this glass fiber, glass fibers, wool, all these are insulating materials and they trap the air. When the air get traps, the air doesn't circulate. We discuss how convection happens. Convection happens through the circulation of the fluid, or the circulation of air. So when this is here, circulation doesn't happen, though, thus it stops the transfer of heat. Okay, and how does the radiation stop? Radiation, okay, it needs vacuum. Okay, and sometimes even these layers, these layers, they are coated with silver color or silver paint, which stops the radiation as well. Okay, so next is about the window. Now this is known as double glazing, which is made on the windows. Okay, so this double glazing wall is nothing but two layers of glass, two layers of thick 6 mm glass. Okay, which have a gap. Again, there is a gap. Okay, there is a low pressure gas in the gap. Okay, and this gap is also filled with some dry material, okay, to keep the gas between the glass plane dry, so that it stops convection as well. Okay, so this method known as double glazing also stops conduction, convection, and even radiation. Okay, and finally, loft insulation. That is, loft insulation okay, uh, is found in modern houses. Okay, it uses similar panels to those used in the cavity walls, trapping a thick layer of air. So again, this rooftop, okay, it has a gap inside, but this gap is filled with some kind of material, some fiber or some wool, which stops the air from circulation. Okay, this stops, okay, convection. Okay, so this is how conduction, convection, and even sometimes radiation is also stopped by painting it with silver color or silver paint or something like that. Okay, and also we can also have these thermostats and computer control system, which will give more efficiency. That is, when a temperature reaches to a desirable level, this thermostat, it automatically, it might stop overheating of the house. Okay, it will switch off the heat on its own. Okay, the next topic is about wind chill factor. See, our body needs heat, okay, because we are uh, beings who need heat inside the body. The blood, it circulates only when it is hot enough. Okay, it is when it is moist and hot enough. Okay, so when there are chilling winds during winter days, when the chilly wind, when it falls on our skin, there is a high risk that we will lose lots of heat. Okay, okay, and we will fall sick, or even we might even die. So this is very very important, which we should always consider. Okay, so this cooling effect of winds is called as wind chill factor. Okay, so when this cooling chill wind, when it falls on the body, it can really lead to a rapid heat loss. Okay, and people can fall hypothermic. Okay, hypothermic, remember, when people lose their heat, and when the body's temperature starts to fall and goes to a very dangerous level. Okay, this is known as hypothermic reaction. Okay, so mostly people who climb mountains, okay, usually the doing in higher altitudes, that temperature is very low, and people who who run in a marathon, when they finish their marathon, okay, when they become tired, these kind of people, they are wrapped by a reflective blanket like these, okay, to prevent the heat. So this is known as hypothermic condition. That is when a person starts to lose his body's temperature to a dangerous levels. Okay, so this can prove fatal. Okay, this can even lead to death. Allah forbid. So this is how this is managed by wrapping such people with a very highly reflected blankets, which will really reflect all the IR waves or the thermal radiation back into their bodies. Okay, so even the animals, they manage themselves during cold or winter seasons in the similar fashion, but in a different way. Like for example, birds, they fluff up their feathers. Just look at this bird. This bird is not fat, but what is it is doing is it is fluffing up its feathers to stay warm in winter days, in cold days. Okay, so what happens here is this thickness of the hair, it traps the air inside the bodies, thus it reduces the convection process happening. Okay, the forced convection. Okay, so this is how birds keep themselves warm. And similarly, other animals, they also do certain things. For example, the penguins, they go and they move closer to to trap the air, or to reduce the transfer of heat, the escaping of the heat. Okay, this process, it reduces the conduction process. Okay, and also the convection process. Okay, so this is a cat which is it is shaping itself into a ball kind of structure. Okay, so this also, what it does, it reduces the surface area. Okay, it reduces the exposure to air. Okay, thus reducing the convection process, and keeps the animal warm enough. Okay, so I am just leaving these points to you. Okay, you have to read these points. What you do is, just pause your this video, you just pause it and just go through all the materials which I am showing you on the screen. Okay, so this is regarding how conduction and convection and radiation is stopped. Okay, just go through all these points. We have already discussed this point. I want you to just read this. It has been taken from a very good another textbook of IGCSE Physics. Okay, so now the thing which is running there on the screen, this is regarding conduction. Okay, just pause this video and just read all the points. The next one is regarding convection, and this final one, it's regarding radiation. Okay, so just go through these points, and your homework for today, your assignment will be regarding this flask question. Okay, so this is a vacuum flask. Okay, this vacuum flask is designed in such a way that it reduces the heat transfer. Okay, so you have to write next to each part. Okay, each segment, how, for example, this outer cap, how does it reduce the heat transfer, either through conduction or through convection or through radiation. Okay, so similarly you have to write for plastic cap, for the shiny mirror surface, vacuum, sponge, air, plastic case. Okay, so you just have to answer this way, and I'm sending you a question through Google Classroom. So the usual, as usual, there will be a box. You just have to type, just type this, and type next to this what kind of process it goes under. Okay, then then the answer. This way you just type in the answer. Inshallah, I will correct that and I will mark you, okay, as submission. Till then, assalamu alaikum warahmatullahi wabarakatuh.